Hello and welcome to presentation 3, the third out of 4 installments of the notes on structures and forces for grade 7 science. We are going to be talking about mass, force, load, and stress. The mass of an object is measured by the amount of matter in an object. Mass is generally measured in kilograms or grams. So an elephant would have greater mass than a mouse because it has more matter than a mouse does. The elephant has more matter than the mouse. The mouse is small, the elephant is large. How do we measure mass? We use a balance. It's the most common type of measuring instrument for mass, especially in a science lab. This is called a triple beam balance. You can't really see it here, but what you can see is clearly, but you can see these weights, and you have a set of 3 weights to try to measure things accurately. Mass is used to measure objects because it always stays the same no matter where it's located. So an elephant would have the same mass on Earth as the moon because it has the same amount of matter on Earth as it would have in the moon. The matter doesn't change. The next thing we're going to talk about is forces. Forces are defined as stresses such as pushes or pulls. A standard unit of force is called a newton. 1 newton is a very small force. It's just enough to stretch a thin rubber band. To understand and predict how forces affect structures, you need to find the size of the force. You need to measure it. How do you measure forces? You measure things using a force meter or a spring scale. So this is a spring scale type of force meter. Inside it contains a spring. It has a scale here that will tell you how much force is applied. You attach the thing that you want to measure to the bottom hook here and you hold it by the ring. We use it in the lab for measuring forces. The problem with force meters like this spring scale is that it's not very accurate, but they are not as expensive and they last longer than electronic sensors, which are a more accurate way to measure force. Some forces are very large and some forces are very small. Large and small forces tend to be difficult to measure, especially in a grade 7 science class. To completely describe a force, you need to know 2 things. You need to know how much force you're applying, so its size, and you need to know the direction of the force, the direction that the force is coming from. When we talk about force and mass, we also need to talk about weight. Weight is what we commonly refer to in the everyday world when we're talking about the mass of an object. Weight is also known as the scientific term gravitational force. Gravitational force is defined as the force exerted by gravity on an object. It is measured again in these units called newtons. When we use weight in our everyday world, what we're really talking about is gravitational force. Gravitational force is the scientific term for weight. About 1 kilogram of weight is equal to about 10 newtons of force. Would your weight or mass change if you were in an airplane farther away from the center of the Earth? Let's think about that for a minute. Your mass won't change because the amount of matter that makes up your body doesn't change, whether or not you're close to the center of the Earth or you're up high in an airplane. What does change is the amount of gravitational force your body is exposed to. So there's less gravity way up in an airplane than there is closer to the center of the Earth. So you would weigh less on an airplane than you would close to Earth. When we talk about forces, scientists draw diagrams to picture what forces are acting on objects. A force diagram is a picture that uses arrows to show the strength and direction of one or more forces. Here we have a picture of a force diagram. That middle circle there, sometimes it's a rectangle, represents the objects on the on which the forces act. Every force that is acting on an object is represented by an arrow. The length of the arrow shows the size of the force. In this case, the longer arrow down here represents that this force going down is stronger than the force going up. The direction of the arrow shows the direction of the force. So in this picture, you have forces being applied in two directions. You have an upward force being applied and a downward force being applied. This picture is showing that the downward force is stronger, so the object would move down. What are the types of forces that we need to talk about? One is an external force. So external means outside. These are stressors that act on a structure from the outside. So kicking a soccer ball would add an external force to the soccer ball. Your foot hitting the ball is an external force. An internal force are things that are inside the structure. These are stresses that put on material that make up the structure. So internal forces are what occur inside an object as they react to the forces that are put on an object from the outside. So some external forces that act on objects are things like gravity, or people walking across something, or people kicking something. The internal forces in an object are those forces that keep it looking and acting the way it should, based on those external forces that are acting on it. So internal stresses can change the shape of a structure. So when you push on a ball and the ball sort of squishes in a bit, you deform the ball. These internal stresses, these stresses on a structure can change the shape, and when we change the shape of something, we say it is deformed, and scientists refer to the process of changing the shape as deformation. What are some external forces? Engineers divide the forces that affect buildings into two groups. One is called a dead load. So those are permanent forces acting on a structure. This includes the weight of the structure itself. So the dead load of a house includes all of the materials that make up the building of the house. Those don't change. Over time, this dead load is acted on by gravity and can cause the structure to sag, tilt, or pull apart as ground beneath the structure shifts or compresses under a load. This is a good example. It's the Leaning Tower of Pisa. As they were starting to build this tower, what happened was the dead load in the tower started to cause the ground to shift and the tower to sink. And over the centuries, it has sunk more and more. So the dead load is causing the tower to tilt. What engineers have done in modern times is they've tried to shore up this side so that it doesn't tilt any further. What we also talk about when we talk about structures is this thing called a live load. A live load is a changing or non-permanent force that acts on a structure. So things like snow in the winter is a live load because it comes and goes. The weight of vehicles on a bridge are a live load because they don't stay parked there, they drive over it. Or people walking across things or climbing up stairs or things like that. People don't stay in one place, they move around. So in this case, the people walking across the bridge, the people would be the live load, and the weight of all the materials of the bridge would be the dead load. In this case, the elevator, or the materials making up the elevator, are the dead load, and the people inside it are the live load. Here, The snow on the roof of the house is the live load because it comes and goes, but the weight of the house itself is a dead load. What are some internal forces? One is a tension force. Tension forces are forces that stretch the material by trying to pull it apart. People can measure the tensile strength of objects by measuring the largest pulling force that a material can withstand before it breaks. Here's an example of how to measure tensile strength. You have a force being pulled in this direction, a rope being pulled in this direction. What they're going to do is they're going to measure the force applied on both ends, and just before this rope breaks is the strongest force possible, and that's called the tensile strength. Shear forces are forces that bend or tear the material by pressing different parts in opposite directions at the same time. So we're shearing the paper over here by pulling it apart. Shear strength is measured in the same way that tensile strength is measured. So you apply the largest possible shear force you can before the material can break. And that is called the shear strength. Compression forces are forces that crush materials by squeezing it together. So when you take toothpaste out of your toothpaste tube, that's a compression force. Compressive strength is the largest compression force you can put on an object before it starts to lose its shape or break into pieces. Torsion forces are twisting. So this elastic band here, that's being subjected to a torsion force. Torsion strength measures the largest twist that you can put on a material before it starts to, or that it can stand and then regain its original shape. So this elastic band, you can twist quite a long time. You can twist it a lot, and then it'll bounce back until its original shape. But if you try to do the same thing to a piece of metal, you wouldn't have the same kind of results. So elastic has a higher torsion strength than metal does. Bending forces are combinations of tension and compression forces. So when you bend something, you compress one side and you pull the other side. The strength of a material is dependent on the forces between its particles. Therefore, steel has a higher tensile strength while rubber has a higher torsion strength. So steel, you can pull it and it won't break as easily as rubber will. But you can twist rubber a lot more than you can twist steel, so rubber has a higher